Welcome to the Chapter 6 Part 4 video. This will be 4.4 and 4.6. This will also be the last video of this semester. So your test will be on Wednesday, which is probably tomorrow. So if we start looking at 6.4, we're looking at properties of rhombuses, rectangles, and squares, and these are all special types of parallelograms. Our objectives are to define and classify special types of parallelograms and to use the properties of the diagonals of rhombuses and rectangles. So let's start by defining a rhombus. A rhombus is a parallelogram with four congruent sides. So if we were to draw that, here's my parallelogram, all four sides are congruent. It also has all of the properties of a parallelogram. So the opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, and the diagonals are bisectors. A rectangle is a parallelogram with four right angles. Now, another way to define a rectangle is to say it's a parallelogram with one right angle. But as soon as a parallelogram has one right angle, all four angles have to be right. And that's because of all those properties of a parallelogram. So opposite sides are still parallel and congruent, but now what we have is four right angles. As soon as this one is a right angle, these are supplementary, so that one has to be a right angle, and these ones are congruent, so that's why we could define it with one right angle. And then a square is a parallelogram with four congruent sides and four right angles. So if we take all of the properties of a rhombus and a rectangle together, then we get a square. Now, a square is also the regular quadrilateral. And remember, regular means all angles are congruent and all sides are congruent. So if we have a regular quadrilateral, it is a square. Regular quadrilateral. So let's look specifically at the rhombus. A rhombus has all four sides that are congruent. And this might feel a little bit repetitive, but the reason that it's repetitive is we want to make sure that you understand the differences and the properties for all of these because it can get a little confusing. They're all going to have properties regarding their opposite sides, the opposite angles, congruent angles, and diagonals. And so at the end of this lesson, what we'll do is we'll make a chart with the properties of each of these types of quadrilaterals. So a rhombus has all four sides that are congruent, and we'll go ahead and mark that on our diagram here. It has all of the same properties as a parallelogram as well. Okay, so I'm going to go ahead and draw some of those on here. We have opposite sides are parallel, opposite angles are congruent, and we also know that consecutive angles are supplementary. So let's repeat a few of those properties. All four sides, and this is the key because this is our definition, all four sides of a rhombus are congruent. A rhombus has all the same properties as a parallelogram. So I'm going to go ahead and just mark this as a parallelogram. In a rhombus, the diagonals are perpendicular. This is different than a parallelogram. In a parallelogram, we knew that the diagonals bisect each other. We did not know that they're perpendicular, so this is a new feature. So here we can say the diagonals are perpendicular. I can say that segment BD is perpendicular to segment AC. Also in a rhombus, the diagonals bisect each other. This is a property from parallelograms, but not only do they bisect each other as segments, they bisect the angles as well. And so we can say these two angles are bisected, these are bisected. And since these opposite angles were congruent, if I have the same number and I cut it in half, it will still be the same number. So these are also congruent and these are congruent. So we can say that BCA is congruent to DCA, and DAC is congruent to BAC, but we can also say that those are all congruent to each other. ABD is congruent to CBD, and ADB is congruent to CDB, but we can also say that those are all congruent to each other. Let's look at some examples. In this first example, we know that we're looking for the missing values in the rhombi, or rhombuses, and parallelograms. So here we know that this is a parallelogram. We don't know if it's a rhombus or not. Given ADCB, the rhombus, now we know it's a rhombus. AB is 10, let's mark it on our diagram. AC is 12, hard to mark on the diagram. DE is 8. So what do we know? Well, if AC is 12, remember diagonals bisect each other. And that means if the whole thing is 12, then half is 6 and 6. So we can say this is 6 and 6. So that means AE is 6 because diagonals bisect. BD, that's whole way across, well, same reason. If the diagonals bisect each other, then each of these is half of the diagonal. So BE also has to be 8, which means that BD all the way across is 8 plus 8, which is 16. And again, we can say this is because diagonals bisect. And then we have BC down here. And how do we know what that measure will be? Well, because this is a rhombus, all sides are congruent. And therefore, BC must also be 10. All sides congruent. And that's because it's a rhombus. That's not true of all parallelograms, but it is true for a rhombus. For the next example, we want to find all of the missing values in this rhombus. So again, we're told that it's a rhombus, so we know that all four sides are congruent. In this one, we're looking at angle measurements though. And so this is going to be more about those properties we talked about with angles. And so immediately when I think of a rhombus, I'm going to go ahead and put my right angles in the middle because we're talking about angles and I see that one of them is a middle angle. So we can automatically say that y equals 90 degrees because diagonals are perpendicular. Okay, then we have x. Now x, if you'll remember our diagram from earlier, is part of these opposite angles that are bisected. And so if angle N is congruent to angle P, the whole big angle N and the whole big angle P, then when they get bisected, cut in half, all of the halves are still equal. So we can say that X is 60 degrees because diagonal bisects congruent angles. Okay, and then we have Z. So here we have Z. How do we find Z? Well, there's a couple ways. The most straightforward, I think, is the triangle sum. And so because we have this right angle, a 60-degree angle, and Z, we can say 180 minus 90 minus 60 should give us 30 degrees. So Z is 30 degrees because triangle sum theorem. So all those theorems that we've learned in the past couple of weeks, they still apply. Let's take a look at the next example. In the figure below, AB is parallel to CD. AD is parallel to CB. Find the value of x. Okay, so here we have a parallelogram because opposite sides are parallel. So how do we find the value of x? Well, in a parallelogram, opposite angles are congruent. So opposite angles are congruent. And that means that 3x plus 19 equals 148 minus 19. 3x equals 129. Divide by 3. X equals 43. Okay, if we need to find the measure of angle A, we have another property to use, and that is not opposite angles, but consecutive angles. So what can we say about consecutive angles? They are supplementary. And that means we take 180 minus angle B or D. Now angle B, I would have to substitute x back in, but it's also consecutive with angle D. So I can say minus 148. Right, we knew angle B was 148 degrees because these are opposite angles. And so 180 minus 148 is 32 degrees. And our last example for this section, RHOM is a rhombus. Find the value of x and explain. Well, we know this is a rhombus, which means that all sides are congruent and opposite sides are parallel. And so we're looking at these two angles. Are they opposite angles? No, they are consecutive angles. And we can say consecutive angles are supplementary. And so we can say 114 plus 12x plus 6 equals 180. So 12x plus 120 equals 180, collecting our like terms. 12x minus 120 equals 60, divided by 12x equals 5. Okay, so those are properties of a rhombus. The next shape that we're going to look at is a rectangle. Now, you should hopefully be familiar with a rectangle, but we're going to talk about some properties, some geometric properties relating to a rectangle being a parallelogram. Okay, so in a rectangle, we know that all of the angles are 90 degrees. They're all right angles. And then all of the properties of a parallelogram. So again, opposite sides are parallel. Opposite sides are congruent. Okay, we also know that the diagonals bisect each other and that consecutive angles are supplementary. Additionally, in a rectangle, the diagonals are congruent. So the distance across either direction is congruent. Notice, particularly in parallelograms that don't have not even close to 90-degree angles, if we have like one that's really acute and one that's really obtuse, such as in example 4, we can see clearly that our diagonals won't be the same length. The distance from H to M is significantly longer than the distance from O to R. So if you ever start wondering, does a rhombus have congruent congruent diagonals, you can just draw an exaggerated rhombus, and hopefully that will help answer your question. So what we can say is that EG is congruent to FH. The diagonals are congruent. And since they bisect each other, that means that the halves of each diagonal are also congruent. Okay, so think about if this diagonal length was 4, then each bisected segment would be 2 and 2. And if this is also 4, then it would be 2 and 2. So half of two congruent angles will still be congruent. So that's FD DH, ED, DG. Okay, let's look at some examples with rectangles. In this example, the first example here, we're using the properties of special quadrilaterals. So for this example, we're given that it's a rectangle. We cannot assume that it's a rectangle just because it looks like 90-degree angles. We have to be told. And so now we can go ahead and mark those 90-degree angles. We need to find the following lengths. So we have AD, DC, and BE. We want to find AB. So AB has to be congruent to the opposite side. So that is 16. BC also has to be congruent to the opposite side. So that is 12. DE is half of my diagonal. Diagonals are bisected, and that means these have to be congruent. So DE is 10. So far, those are all properties of a parallelogram. We didn't need the right angles for any of those. But in order to find AC, which is our second diagonal here, we don't have any measurement on segment AC. And therefore, we have to use the fact that this is a rectangle to say that this diagonal has to be congruent to our other diagonal. And so BD, the other diagonal, is 10 plus 10, which is 20, because diagonals are congruent, specifically for a rectangle. In our next example, we want to find the missing measurements in the square. Okay, so what do we know about a square? Well, a square has all right angles, but also when we talk about a square, it means that the sides are congruent. And we'll be talking more specifically about properties of a square in a little bit, but you already know some things about a square. So let's look at SA. Well, a square is a rectangle, right? This is a rectangle with congruent sides. And therefore, it has all the properties of a rectangle, namely that all of our diagonals and half of each diagonal is congruent. And so SA, which is half of a diagonal, is congruent to this other half of a diagonal that we have, 7. BA is the whole diagonal, so each half of a diagonal was 7, then BA is 14. And BD, well, that's a side that's not a diagonal, so that's congruent to the other side that we have, 7 root 2. Because diagonals are congruent and sides are congruent. Let's take a look at the next one. In the rectangle below, we have that NQ is 4x plus 5. OQ is 6x minus 5. MQ is 5x minus 5. And PQ is 3x plus 15. Solve for x and explain. Well, because this is a rectangle, all of these are congruent. So we can choose whichever two we want to set them equal to each other. I'm going to go ahead and choose the ones with the smallest coefficients, but honestly, it could be any of them. So let's start. 4x plus 5 equals 3x plus 15 minus 3x minus 5. X equals 10. Now, if we wanted to double check, we can go ahead and substitute that in. And because it's 10, it's not too bad to multiply. So 45. I copied this incorrectly. This should be minus 15. Okay, 60 minus 15 is 45. 50 minus 5 is 45. 30 plus 15 is 45. Phew. Okay, so they all equal 45. So x equals 10 because we have that diagonals are, because we used 2 from the same diagonal, we're going to say they're bisected. We use the fact that 2 halves of the diagonal are equal to each other. In number 4, we have a square. Square means the sides are congruent, the diagonals give us congruences, and our corners are 90 degrees. Find the measure of angle RSE. Okay, so we don't know about this angle, but we do know that in a rhombus, the angles are bisected. So the question is the square a rhombus? Well, it is a parallelogram. Opposite angles or opposite sides are parallel, and all four sides are congruent. So yes, this is actually a rhombus, and therefore that angle is bisected. Remember, that was one of our features or our properties of a rhombus. And since the angle is bisected, that means we took a 90-degree angle and we cut it in half. So 90 over 2 is 45 degrees. So that makes this 45 degrees. The measure of angle QEU, while this is a rectangle, we talked about defining it as a rectangle, and therefore the diagonals are congruent. But now we're talking about it in terms of a rhombus, and for a rhombus, the diagonals are perpendicular. And therefore, angle QEU is a right angle with a measurement of 90 degrees. And both of those are because a square is also a rhombus. And lastly, we'll look at the measure of angle SRU. Well, we did define a square so far to be a rectangle, which means that it has 90-degree angles. And so SRU, which is an outside angle, is 90 degrees. Right, that's one of our big total outside interior angles. In our next example, we want to use the quadrilateral in the question below, and we're not told if this is a rhombus or even a parallelogram. We just know it's a quadrilateral. And so what we want to do is explain why is this quadrilateral not a rectangle? So what is it about this that makes it not a rectangle? Well, we do have diagonals that are bisected, which means that this could be a parallelogram. However, in a rectangle, those diagonals need to be congruent, and 9 and 8 are not equal, and therefore diagonals are not congruent, so it can't be a rectangle. Okay, and then our next example, classify the figure below and explain. So we have this figure here. We say the interior diagonal angle is 90 degrees. Okay, well, if it's 90 degrees, that could make it a rhombus. It could make it a square. It doesn't rule out a rectangle, but because these diagonals are different lengths, it can't be a rectangle. So let's start with can't be a rectangle because of the diagonals. It could be a rhombus. Could it be a square? Well, no, it can't be a square because it's not a rectangle, right? If it's not a rectangle, it can't be a square. And all of these are types of parallelograms. So we have a right angle in the middle, could be a rhombus. I have bisected diagonals, could be a rhombus. And I have diagonals that have different lengths, could be a rhombus. And so we can say that this one is a rhombus, given that it's one of the shapes that we are looking at. And we'll be able to prove that this is a rhombus later on. Okay, so that's rhombus or rhombuses, rhombi, and also rectangles. And we've also looked at some properties of squares, so let's see if we can fill those in. So a square is when all sides are congruent, and that's what makes it a rhombus, and all angles are 90 degrees or right angles, and that's what makes it a rectangle. So we have all right angles and all sides congruent. So that makes it both a rhombus and a rectangle. So what are the properties that we know? Well, we know that this is a parallelogram. All of these are parallelograms. So all properties of a parallelogram. We know that all interior angles are 90 degrees. We know that all sides are congruent. Okay. We even know that the diagonals, if I draw them in here, are congruent and bisecting. Diagonals are congruent. Diagonals bisect each other. And we also know that those diagonals are perpendicular. Okay. We also talked about how each of these angles that's bisected is 45 degrees, but that's kind of a secondary property. So let's look at a couple of examples. In our next example, we're picking numbers for the sides and segments of the diagonals to create a rhombus. So we know that all four sides are congruent, the diagonals bisect each other, but for a rhombus, the diagonals don't have to be equal to each other. They don't have to be congruent. So we need measurements. We can pick some numbers. Now, if we want this to be truly a rhombus, this needs to be a right angle. And so we need to pick what are called Pythagorean triples. Pythagorean triples are the sides of a right triangle. So they work perfectly into Pythagorean's theorem. Okay, and remember Pythagorean's theorem, a squared plus b squared equals c squared. So one of the most commonly used Pythagorean triples is 3, 4, 5, because 3 squared plus 4 squared equals 5 squared. They're nice small numbers. It's nice that they're consecutive. So let's go ahead and use those numbers. So we have 3, 4, 5. And remember, 5 is always going to be the hypotenuse. And the nice thing about a rhombus is we can just fill in with those three numbers. Now, if you'll notice, this also shows us that a rhombus with its diagonals creates 4 congruent triangles by SSS. Okay. For our next example, these are not the numbers you have to use. This is just one example, right? You're just picking numbers. You could have chosen different numbers. For our next example, we want to find the values of x and z. So what do we know? Well, we know that these two sides are congruent and that's a right angle. So since we're talking about parallelograms, we're going to go ahead and say this is a parallelogram. If there's one right angle, they all have to be right angles. If the sides are congruent, right, opposite sides are congruent. So since those two consecutive sides are congruent, then all four sides are congruent. So this is a square. And that means that 9x equals 45. Divide by 9, x equals 5. And 18z equals 45. Divide by 18, z equals 2.5. Where did the 45 come from? The 45 comes from our previous example on the last page, where we saw that because these are angle bisectors, bisecting a 90-degree angle gives you two 45-degree angles. Okay, let's take a look at our next set of practice problems. So now we're kind of looking at a mixture of rhombus, rectangle, square, parallelogram. So for this example, we have a rectangle, CURD, that has diagonals CR and UD that intersect at A. So let's draw a picture. Rectangle, CURD. When you name a quadrilateral, it doesn't necessarily go clockwise or counterclockwise always, but they should, once you start in that direction, they should always go in that direction. So I wouldn't go CURD because that crossed through my rectangle. So I could have gone CURD, or CURD, then not CURD. And so we have these diagonals, CR and UB, that intersect at A. DA is 4x minus 7. CR is 58. Find the value of x. Well, because this is a rectangle, we know that diagonals are congruent and bisected. And so we have all of these congruence ticks. And so if DA is 4x minus 7 and CR is 58, well then each of my halves of my diagonals is half of 58. So the way we can write that is we can either say that 4x minus 7 times 2, because there are 2 halves to each diagonal, equals 58. Or we can say that it equals 58 divided by 2. It's half of the diagonal. You get the same answer either way. I chose to do it this way because I'm dividing the side that doesn't have a variable. So 4x minus 7 equals 58 divided by 2 is 29 plus 7. 4x equals 36. X equals 9. And we did that because diagonals are congruent and bisect each other. Sorry, I had trouble spelling during that sentence. Diagonals are congruent and bisect each other. For our next example, we have ABCD. We're told it's a parallelogram. I'm going to go ahead and mark that. If AO equals x plus 4, BO equals 2y minus 6, CO is 3x minus 4, and DO is y plus 2, solve for x and y. Well, this is not a rectangle, this is a parallelogram, so I know that the halves of a diagonal are congruent, but the other diagonal halves are not necessarily congruent, right? That was just a property of rectangles, and therefore squares. This one, diagonals bisect each other, but they're not necessarily congruent. And therefore, we can set the 2 halves of the diagonal equal to itself, but not to the other 2 halves. So we're going to do 2 equations here. X plus 4 equals 3x minus 4. And also, 2y minus 6 equals y plus 2. Subtract x plus 4. 8 equals 2x. Divide by 2. X equals 4. Over here, minus y plus 6. Y equals 8. For example 3, I should say part 3. Use the quadrilateral to answer the question below. So here we have a quadrilateral, does not tell us if it's a parallelogram or not. Explain why it is not a parallelogram. Well, what are some of the properties of parallelograms? Here we have diagonals labeled, so let's think specifically of properties of parallelograms' diagonals. And we know that the diagonals bisect each other, which means 4 should be congruent to 4, and 5 should be congruent to 6. But 5 does not equal 6, so the diagonals do not bisect each other. So it can't be a parallelogram here. So let's pick some numbers that would make it a parallelogram. Well, they don't have to be the same numbers from above, but let's use those. 4 and 4. And then we can do 5 and 5. That would make it a parallelogram. Or 6 and 6. Or you can make up your own numbers. Okay, and the next part, we have the given quadrilateral is a rhombus. Which of the following are true statements regarding the rhombus? Well, if this is a rhombus, we need all 4 sides to be congruent. We need all inside diagonal angles to be right angles. And we had these 2 congruences where all of the opposite angles are congruent, and therefore the opposite angle halves are also congruent. So does A equal H? Yes. Does D equal 90? Yes. A plus C plus D equals 180. A plus C plus D can't be 180 because C plus D equals 180. So no. A plus F equals G plus H. Yes, opposite angles are congruent. And A plus B plus I, we're going around the side, plus G plus H plus J plus E plus F is 360. Well, we know that the angle sum for a four-sided figure is 360, so yes. So the only one that's not true is part C. Let's go ahead and look at our last page. So this page is kind of summarizing the things that we've talked about. A quadrilateral is a polygon with four sides. That doesn't mean any of the sides are congruent, doesn't tell us anything about the angles or the relationships between those sides. Any polygon with four sides. And remember, a polygon just means a closed figure that only intersects at endpoints. So something like this is a polygon. Something like this is a polygon. As long as it has four segments that are joined at the endpoints. A parallelogram then means we take that quadrilateral and we give it two pairs of parallel sides. If we give it further restrictions, we can say we also have a right angle, or we also have congruent sides. And if we have both of those, then it's a square. So let's look at classifying these. Classify quadrilaterals. Be as specific as possible based on what you are given. In part A, we have that all four sides are congruent. Well, remember, we said that if opposite sides are congruent, then it has to be a parallelogram. So this is a parallelogram with four congruent sides. What we don't know is if those angles are right angles. So all we can say about this one is rhombus. On part B, now we do have right angles, but we have opposite sides congruent, but not all four sides congruent. So that is a rectangle. In part C, we have four sides, but that's all we know. This is a quadrilateral. In part D, we have four right angles, but we don't know anything about the sides. Well, if it has four right angles, this has got to be a rectangle. In part E, we have opposite angles are congruent. We don't know anything about the side lengths. Therefore, all we can say about this one is parallelogram. And lastly, we have four congruent sides and four right angles. That makes this one a square. Okay. Again, at the end of this section, we'll go ahead and put some of these properties into a nice table to talk about. But in the meantime, there's one more type of quadrilateral, well, two more types of quadrilaterals that we want to talk about, which are non-parallelograms. So let's take a look at our last section of notes. Section 6.6, we're looking at trapezoids and kites. Now, trapezoids and kites are different from parallelograms because it does not have two pairs of parallel sides, but they do still have some special properties. So our objective for this section is to verify and use the properties of these two new shapes, trapezoids and kites. A trapezoid is a quadrilateral with exactly one pair of parallel sides. And that means here's a parallel line to this, and then it has two sides that join up, okay? It just has one pair of parallel sides. If the other pair of sides was also parallel, it would be a parallelogram. The parallel sides of the trapezoid are called bases. So that makes this a base and this is a base. The non-parallel sides are called legs, similar to a triangle. Leg, leg. The two angles that share a base are called base angles. So here we have two base angles and base angles. Here we have two base angles. So the pair of base angles shares a base. It's the two angles along one of the parallel lines. Base angles. And so we can see there are two pairs of base angles. A very special type of trapezoid, this should be a P, trapezoid, is a trapezoid with congruent legs. Now when we have a trapezoid with congruent legs, kind of like a congruent triangle, we call it isosceles. Notice we mark it the same way, but now we have, it's like an isosceles triangle that got split so that it had a flat top. Okay, it got a haircut or something. So this is an isosceles trapezoid. And if we're looking at any trapezoid, so this is not just for isosceles trapezoids, this is for any trapezoid. That means we can find the midpoint of each of the legs and draw a line across, and that line is called the midsegment. So a midsegment joins the midpoints of the two legs. And that's for non-isosceles trapezoids as well. So let's look at some of these properties that we get from a trapezoid. One of the main properties is that when we draw in the midsegment will always be parallel to the bases for a trapezoid, which means here we can say that RA is parallel to MN, and MN is also parallel to TP. The length of the midsegment is the average of the bases. And remember, to find an average, we add them together and divide by how many there are. So in this case, MN is equal to RA plus TP divided by 2. We also know that for an isosceles trapezoid, just like for an isosceles triangle, the base angles are congruent. And so we have two pairs of base angles here and here. So we can say angle T is congruent to angle P. Angle R is congruent to angle A. And in an isosceles trapezoid, the diagonals are also congruent. And so we can see this diagonal, BD, is congruent with our other diagonal, AC. Let's look at some practice problems. In our first practice problem here, we have CDEF, and we're told that it's an isosceles trapezoid, which means that the two legs are congruent. We want to find the measured angle D, E, and F. Well, to start with, I can say this angle along the parallel line is congruent to this angle. So angle F is 65 degrees. That's by congruent base angles. We also know that angle D will be congruent to angle E. So angle D, I should say measure. Measure of angle D equals measure of angle E. But how do we find out what that measure is? Well, if we remember parallel lines with a transversal, we can draw our Z. And so we have consecutive angles. And that means that angle C plus angle D must be 180. So 180 minus 65 will give me angle D. That's 115. Supplementary consecutive angles. For number 2, we have QR is a midsegment. Midsegment means that it connects the two midpoints of L, M, and P. Find X. Well, the calculation for a midsegment is that QR, the midsegment, is the average of the two bases. Lm plus Pn over 2. Notice I can multiply both sides by 2 if I don't want to deal with a fraction. So let's go ahead and do that. 2 times QR equals Lm plus Pn. Pn is 8. Lm is 4x minus 10. And QR is x plus 2. From here, we solve algebraically, distribute that 2. 2x plus 4 equals, collecting like terms, 4x minus 2 minus 2x plus 2. 2x equals 6. Divide by 2. X equals 3. And we did that by our calculating the midpoint. Mid segment equals average of bases. Our next example, we have another mid-segment, so we're going to use the same formula. I'm going to go ahead and skip to the second part where we had multiplied by 2, so the mid-segment is 2 times the sum of the bases. 2 times mn equals qr plus ps. And again, we're finding x. So I'll substitute 2 times 2x plus 11 equals 10 plus 8x minus 12. That gives us 4x plus 22 equals 8x minus 2. Minus 4x plus 2, divide by 4, x equals 6. For number 4, we have an isosceles trapezoid. I'm going to go ahead and mark my angles here. Find all the other missing angles. So here we have angle R is 106. Angle S, measure of angle X, is 106 degrees by consecutive base angles. And we already know the trick here is that these are consecutive angles. 180 minus 106 gives us 74. So the measure of angle Q equals the measure of angle P, which equals 74 degrees. If it confuses you to look at your trapezoids on the side because the parallel lines are vertical now instead of horizontal, you can always turn the page. Or, if you prefer, you can redraw your trapezoid. Okay. So that's trapezoids. Our second type of figure that we talked about, or that we said we were going to learn about in this section, is a kite. Now think about a kite that you might see on TV, or you might have flown on the beach or in a windy area. They're kind of shaped like a diamond that's been elongated on one side of it, right? And so when we think about a kite that we fly in the sky, we have this kind of idea of kite shapes. And that's exactly what a kite in geometry is. It's like a diamond that has been elongated on one side. So our definition is that we have 2 pairs of consecutive sides that are congruent. Notice none of these sides are parallel. Okay? So some of the properties that we get are that the diagonals here are perpendicular. And that's part of the reason that makes this kite structure so good for flying, is that those perpendicular diagonals are usually where we have a wooden brace or something, maybe a piece of metal to keep the kite in its shape. So the diagonals are perpendicular, which means that AC is perpendicular to BD. Let's look at some examples. So we'll do number 1 together. I'll leave number 2 and 3 for you to do as a try this, see if you can apply some of the things that we've learned about kites. But there is a little mini proof that happens in order to finish number 1 that I'd like to go through together with you. So We said that a kite's diagonals are perpendicular, and that means when I see this diagram and it says that it's a kite, I'm going to go ahead and mark congruences and those right angles, similar to a rhombus. And we want to find the measurements of angles 1, 2, and 3. So right away I can say the measure of angle 1 is 90 degrees because diagonals are perpendicular for a kite. Okay, to find the measure of angle 2, I can use the triangle sum theorem. So the measure of angle 2 equals, I'm going to use triangle sum theorem to say this is 180 minus 90 for angle 1 and 52 for this other angle. And that gives me 38 degrees. And then the trouble comes to angle 3. And what we actually can use to find angle 3 is that if we're looking at this kite, we know that these two angles are, or side lengths are congruent. We know that there's a reflexive side here. And so we have these two triangles, E, D, let's call that C, and D, C, G, congruent sides, right angle. And so by HL, these two triangles are congruent. Now angle D, we know here is 52 degrees. That's between the 1 and 2 sides. So between the 1 and 2 sides, angle 3 must also be 52 degrees. And we can find that by HL congruence. And CPCTC. Okay. You use something similar for numbers 2 and 3. And then lastly, to help keep all of this straight, let's look at our flow chart. I'm showing you the one directly from the book because I can't draw it that neatly. But we start out with a quadrilateral. Then we can say if I have no pairs of parallel sides, it could be a kite. If I have only one pair of parallel sides, that makes it a trapezoid. And our special type of trapezoid is if those legs are congruent, then it's isosceles. If I have two pairs of parallel sides, then it has to be a parallelogram. If the sides are all congruent, it's a rhombus. If the angles are all 90 degrees, it's a rectangle. If I have both of those, then it's a square. Okay, we'll go through the properties of those in class together.